Alright, good day everyone. You are welcome back again to Chemistry Simplified. So here we identify tough topics and we make all tough topics look very simple to you. Alright, without wasting our time, for my JAMB out there, please make sure you like, share and subscribe and click on the notification bell to get notified whenever I drop and a part 2 video just like this. Alright, so now I'm going to be explaining about a man on a lift. A man on a lift. But don't forget that this particular topic, a man on a lift, is not in chemistry. That's simplified, but I have some videos on physics like that. So the topic is on what? Is on physics. So it's actually due to a popular demand. So you see, if you put your down remix, chapter 3, under the concept of motion, you have these many questions from this particular topic there. So I'm going to be doing the first part of the video today. Then the next day, I'm going to be doing the following part of the video. I just have to make the video very possible tonight. Alright, so let me just explain and follow me through. I want to show how to derive the formula yourself. So let's assume if this is a village and this is you are watching me. Very funny, right? Okay, and the lift will be tied to a what? It will be tied to a particular source on it. The lift will be tied to a particular source on it. So it's actually a practical stuff. I would have made some things available to explain this, to explain the practicality of this, so that you can understand. Now, I'm very sure that you are not new to physics. You know that if you are standing on a plane surface, you are exerting a particular force on that ground, right? That force you are exerting on the surface is known as your weight. Why? This is the rope or the string that hold on the whole lift. Now there is a force here. There is an upward force that is pulling the lift upward, that makes it to stand freely here. So that force in the rope is known as what? As tension. Tension is also a force, F. So we have two forces that is acting here. So we have an upward force called the tension, and we have the downward force of the man called the weight. Do you understand? It's very simple stuff. For example, if you have any big maybe a bucket, yeah, very fine now. If you have a bucket full of water and you are trying to carry the bucket with your hand, or you use let me use this word, let me use this example, you use an handkerchief to carry the water in the bucket. Why the bucket will feel so heavy is because that the water in the bucket is pulling the weight of the bucket downward. That's the weight. But the power or the force you use to hold on to the handkerchief, you are exerting that force in the handkerchief so that you'll be able to carry the bucket upward. Do you understand? So the force you are exerting is in the handkerchief, and that handkerchief is serving as a rope of this lift here, which is what? Tension. Do you understand? So there are two forces that is acting on a man on a lift. You have the downward force called the weight, and you have the upward force called the tension. Do you understand? Alright, now for a man on a lift, there are 4 things that will happen to a man on a lift. There are how many things that happen to a man on a lift? 4 things. Number one thing that can happen is that if the lift is moving downward. Number 2, if the lift is moving upward. Then 3, if the lift is stationary. And last one, if the rope of the lift cut suddenly. So these are 4 things. are the four things that can ever happen to what? To the lift. The lift can either move downward, either move upward, or the lift is not moving at all, or the rope suddenly cut. These are the four things that can happen. So I'm going to be explaining part one now. Let me explain this first that we have here. If the lift is moving downward, I want you, just like I always say to my students, I don't teach you to guess questions. I teach you to understand questions. Do you understand? It is crystal clear that if the lift is moving downward, don't forget that there are two forces that affect the man in the lift. And we have the weight and the tension. Now, if this body now can pull the weight of the lift downward, what does that mean? It simply means that the weight of the body is higher or greater than the tension in the rope. Let me repeat. It is very, very simple. You recall the example I gave you. Bucket, handkerchief, your force. You remember, right? If you hold the handkerchief, if you are unable to carry the bucket full of water, what does that simply mean? It simply means that the weight of water in the bucket is greater than your force. Do you understand? That does it. So now you have an unbalanced force there, Abi? Yes. So now I will call that one case 1. So if the case 1 is if the lift is moving downward, and if the lift can move downward, it means that the weight of the body inside the lift is greater than the tension in the rope. That means there's an unbalanced force. The force here, you have the weight greater than the tension. That means you have the force to the weight minus the tension. And don't forget, if you are to make your T SOF, if I say SOF in this class, it means subject of formula. If you want to make this T subject of formula, we have T equal to, you bring this T here, you bring this F here, minus T returns to what? Plus T. F returns to minus F. You now have weight minus F. Do you understand? Therefore, what will now happen? You now have T equal to, what is formula for weight? Weight is what? Mass times acceleration due to gravity. You have mg minus force is what? Mass times acceleration. You have ma. So what is common here? Mass and mass. Then you can factorize the mass out. So you have T equal to m open bracket g minus a. Do you understand? Very, very simple, right? Yeah. So let me explain the case 2. Then I'm going to be talking about the case 3 and case 4. Then we now move to solving a lot of JAMB past questions in our next class. Now, if the lift can move upward, now you can pause the video and tell me the answer, right? So you know what happens there. If the lift can move upward, it means that, let me now recall back to the example I gave. You have the bucket of water and you have the handkerchief. If you can carry the bucket of water, what does that mean? It means your force that you apply to that handkerchief is greater than the weight of the water. Yes or no? Yes. It means the tension is greater than the weight of the body. That is, you don't have to cram it. You just have to understand it. Then it means that you have T. Sorry, the unbalanced force there now because what? Your T is greater than your weight, which means the weight, in other words, T minus weight. The same thing, make your T the SOF. So then you now have T equal to, you bring this minus F to this place, not equals to F plus W. So our tension will now be equal to, what is F? MA plus what is W? MG. Then you are going to factorize M out, so you have T, what is M? A plus G. Do you understand? So this is the formula you have to use whenever you hear that a lift or elevator or a body is moving downward, upward rather. Case 1 is what? Moving downward. Case 2 is moving upward. So in our next video, I'm going to be explaining if the lift is stationary and if the rope of the lift suddenly cuts. So I'm going to be coming with full JAMB question. Stay tuned to this class. Make sure you subscribe, like, and share. Thank you very much for watching this video. Love you.